Okay. Hello, everybody. Welcome. This is the OKC Python meetup hosted by Techlahoma at Starspace 46. Today I'm going to be talking about Unicode in Python. My name's Toby Nance, and this presentation is hosted on GitHub under the OKC Python GitHub group and under the repository Unicode. Before I get started, I had a quick survey for the crowd. It's been a while since we've asked some of these questions, and I kind of wanted to get a feel for where people are at with Python. Doing a quick count, I think there's about 16 people here. So if people can just show me with a show of hands, how many people here currently use Python as part of their job? I see 10. All right. How many use it as a hobby? You can go twice. Yes, definitely. So 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, quite a bit of overlap. How many would say that they do not currently use Python, but they're interested in the language? 2? That was a weird, there's some weird overlaps here. Sure. All right. We have some pedantic people in the audience. And is there any other answers if somebody feels like I didn't cover a use case that they feel should be covered? Yes? I know some people who just use Python for DevOps. Okay. So there's the case of using Python for DevOps. I'm going to consider that use Python. I see no real distinction there. Like, it doesn't have to be that a traditional development house for it to count. Okay. So. Yeah, I just recently worked at a place that was Java top to bottom, but DevOps all in Python. Mm-hmm. And I think that's an interesting distinction. Okay. So Greg said that Java top to bottom except for DevOps, which was all Python, and I think that's not that uncommon. And I think that would totally count. I don't see the distinction that DevOps doesn't count as programming. So. All right. So, as far as what people use Python for, would you say that you use Python for completing tutorials? No? All right. What about serving web pages? 1, 2, 3, 4. 8. What about web scraping? 1, 2, 3. 6. Okay, 6 people. And I called it data processing analysis. Feel free to argue that I need to break that apart into something. EDI? Like electronic data interchange, like invoices and like business logic and yeah, I would count that. Yeah. So anyway, sorry, hold your hands back up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Interacting with real-world sensors. 1, 2, 3, 4, 5, 6, 7. I feel like 4 of most of them. Yeah. Yeah, there's definitely going to be overlap between these, obviously. These numbers do not add up to 16, and I think that's fine. What's some other use cases for people using Python that you don't feel is covered by those? Well, specifically testing. Testing? Yes. How many people would say that they use Python for testing? 4, 5. Testing Python. I guess that's a good question if you're testing your Python code. But yeah, let's say specific testing other code. Just here I am going to go ahead and assume that you're testing your own code if you're using Python for Python's sake. So for testing non-Python code, that would be no one? Testing web apps written in everything. That's true. So that's what I'm doing. I mean, that's my most common case. Okay. Like every day. All right. I'm going to give that a 1 then. 2. All right, any other use case that feels like we need to cover? Scripting. And how would you define scripting? Writing scripts. Automating tasks.
Yeah, you're my definition of a script in Python is it's almost all left justified.
Okay.
And it just runs top to bottom.
If it has if name equals main.
Okay, so the idea would be if it's largely left justified, so there's not a whole lot of indentation. If it has a if name equals main, so it's got a main.
It's structurally Fortran, top to bottom.
Yeah. So how many people would fit into that? 1, 2, 3, 4, 5. 5?
Those DevOps scripts.
All right. Okay. So how many people would say that they use Python version 2 and they plan to go to version 3 only if forced to? 1?
Yes, 1.
All right. Version 2 and plan to go to version 3 as soon as they can. 3, 4, 5. Who currently use Python version 2 and version 3? 1, 2, 3. Using only version 3? 1. Using version 3 but plan on going back to version 2? 0. Just checking. I would have been surprised, but I also didn't want to ignore it. Is there any other use case, like on the versioning of Python, that you feel like wasn't covered? Is anyone using version 1? No? All right. Oh, I guess that's a good point. Is anyone using Jython?
I was forced to.
Okay, but no one's currently using it? And PyPy? Nope. Okay.
Code tests that work under Python.
But not really using it? Okay. All right. So if I ask the question, the thing I struggle the most with Python is, anyone have any answers?
Unicode.
All right.
Going back and forth. Yes, that I did not think.
All right.
Most languages have that.
Yeah. I mean, it's a common problem. Anything not pertinent to today's talk?
Well, using let's for example, specifically, this is my thing. It's thing I learned at school. You're on a system that has old Python, new Python with SSL. So you've got to do all the things, to get that all in. And Python insists on not making binary packages available in any real official way. So you end up compiling Python, which is like a terrible idea. So it's the, roll your 2713 on a system that's got AKA 1, 2.
Okay.
I run into that problem all the time.
Yeah.
So I have to infect the machine with all the things that I need. Sometimes the customer's not very happy.
Yeah, but just to be able to get it on there so you can even do your work.
Right, so you can do Python with SSL.
Okay.
That's that half an hour every.
Yeah. All right. Two different? All right. Probably if we were going to do a talk about it, they would probably go together, I guess is my thinking. Anything else? How many people would say that they struggle with Unicode? Sure. 2. Byte strings? 1. 1.5, 2. Having to compile Python and Python packages?
He doesn't struggle with it.
Did you? I think. Versioning and distribution? I'm going to include myself in that too. 1, 2, 3, 4. Okay? And how would you answer the question, the thing I enjoy the most about Python is?
Libraries. That's it, man. That's what I'm there for. I'm not there for this.
That's part right.
All right, I was going to say the built-in libraries, but yeah.
Yeah.
Anything else?
I mean, pretty much it. I like the nature.
Yeah.
So many things.
Yeah. Heard the answer of just really enjoying the clean syntax and layout of it.
Is better than implicit thing.
Well, yeah, and that leads to, forgiveness, right? That principle is excellent. One phrase, design pattern, makes code not look horrific.
Yeah.
I mean, I'm a C programmer, so if the open fails, do this. If the write fails, do that. If the close fails, do this.
Yeah.
Completely ridiculous.
All right. How many people would say that the thing they like most about Python is the libraries? If you could restrain yourself to one, that would be good. So 1, 2, 3, 4, 5. Forced indentation. 1, 2. Explicit is better than implicit. 1, 2, 2. The forgiving nature of Python.
I meant it's better to ask for forgiveness.
Oh, better to ask for forgiveness.
So the exception pattern.
The exception pattern.
Just do things in a normal way and handle the blow up later.
Would you say exception handling covers that?
I would say specifically the exact phrase.
All right.
To me, that's one of the overriding design.
You feel like that still actually is fitting with what you were going to say? All right.
In Java 9, it's better to add more annotations than that design.
Yeah. Okay. Cool. Thank you, everyone. I just wanted to get a feel for where people were on that. Just a few questions, and that's it. And then we're going to jump right in. Okay. I am not going to claim at all to be an expert on this topic. So this, I would say, is more out of need than authority as far as this talk. So some conventions I'm going to use during this is I'm going to say bytes or byte string to mean the Python 2 str type and the Python 3 bytes type. I'm going to say Unicode string to mean the Python 2 Unicode type and the Python 3 str type. I really want to call those text string instead of Unicode string, but I feel like that would be confusing as we go through this, so I'm going to call them Unicode string. And I'm going to be prefixing my string literals with either a B or a U to make it obvious which of the two I mean. So as an example of what I mean by that, you'll see that string literals are going to have either a B or a U at the beginning. Okay, jumping right in. I also did a from future import print function so that as much as I can, this will behave the same on Python 2 and Python 3 as we go through it. There may be something that doesn't work quite the same. Hopefully everything works the same on Python 3. I was running this on Python 2. So as an example, whenever you use the BPrefix, you're creating a byte string, which is a stream of bytes. And you can get away with embedding Unicode characters within it. So as an example, I put the copyright symbol, but you can see that it actually takes up 2 bytes in the output. So let's say I want to convert this byte string into Unicode. I can call Unicode on it, and that will fail with a Unicode decode error, saying that the ASCII codec can't decode it. So what's the correct way? I can try calling encode Latin 1, and that'll give me a Unicode decode error. I can call encode UTF-8, and that gives me a Unicode decode error. I can call decode ASCII, And finally, I can land on, if I call decode Latin 1 and it doesn't break, but if I print it, I see that I now have a weird symbol in the output string. And then I can call decode UTF-8, and this results in a Unicode string that has only one character at the beginning, and when I print it, it looks the way I expect. Okay, so that's my final example of that. So what does it take to get back to a byte string? Okay, so I can try str on my Unicode string, and I'm going to get a Unicode encode error. I can call encode to ASCII, and that's going to result in a Unicode encode error. I can call encode UTF-8, and that one works. I can call decode UTF-8, and that's a Unicode encode error. And you can call decode ASCII, and that's a Unicode error. I find it to be a dizzying array of things you can try with it not being clear what is actually going to work. So, how can you make sense of all the different options you got? This is how I wrap my brain around it. Anytime you do a text.encode, encode I think of as serialize, it always returns a byte string, whether text was originally a byte string or a Unicode string. In Python 3, you can't even call encode on a byte string. You then call text.decode, which will always return a Unicode string. So encode always goes to byte string, decode always goes to Unicode string. So basically I just try to remember the part of you encode text as bytes using a particular encoding, and then derive from that the idea that you decode bytes into text by knowing what the encoding was when you serialized it. Okay, so given all those examples, here's the actual examples that worked. Byte string.decode, and you give it UTF-8. To convert a Unicode string to a byte string, use Unicode string.encode UTF-8. Any questions so far? Cool. So, there's a question that someone had posed, which is a Unicode string the same thing as UTF-8? And the answer is no. UTF-8 is a way to encode text as bytes. UTF-8 would be a byte string that is the serialized form of a Unicode string. Also, UTF-8 isn't the only way to encode Unicode strings. As an example, there's also UTF-16 and UTF-32. And here I'm just showing an example of, I have a Unicode data, and when I encode that as UTF-8, I get a byte string, and then I can also encode it as UTF-16. Some of the interesting things about it is my original string, if you just count up the number of characters, is 18 long, but the UTF-8 byte string is 21 bytes long. The UTF-16 byte string is 38 bytes long. And if you do some quick math, 18 times 2 is actually 36, so it gained 2 extra beyond what seems like it would need to. And the reason is every UTF-16 string starts with a hexadecimal FF, hexadecimal FE. That's the way it's a, oh, what is it? It's not the byte order, is it the byte order mark for UTF-16? To be able to mark that this, so that something reading this can try to make sense of it and understand that this is UTF-16 that it is reading.
It's intended to
Right, and so I think, yeah, on some systems those two might be inverted. When doing like networking and things like that, you might run into an issue where those two are inverted and you have to deal with that. So, there's other encodings besides just UTF-8. The most common one for, I'm going to guess, and I could be wrong, for people in this room would be Latin 1, also known as ISO 88591. And Another one that I've run into before is Windows 1250, which is for Central and Eastern Europe, if working with European data. I used to work in mapping, so I had to deal with like streets, street addresses and stuff like that, and having to deal with the addresses that had European characters in them. So here I've just taken the string 2017 OKC Python and converted into UTF-8. I then also, UTF-8 byte string, to be clear. I also encode it as a byte string that is encoded Latin 1 and a byte string that's encoded for Windows 1250. All of those have the same length and the exact same contents, which begs the question, how can you tell, looking at the output, what went into it? And the answer is you can't. There is nothing in there that tells you what the type, what was the encoding that happened. This can be really frustrating if you're parsing data and you weren't given the information about how it was encoded, and you're just trying to figure it out by when it crashes, what type of character was this and what code type, like what care point was it, so that you can try to figure out what makes the most sense. It's not simple, and it normally happens in production, in my experience. But them's the breaks. So as an example, where you actually have some characters that are not just plain ASCII, I have the copyright symbol and an O with a, anyone know what that one is? It's not the umlaut, but carar? Caret. Oh, that's just caret. So if you convert that to UTF-8, that ends up being 20 instead of 18 characters long. Latin 1 being 1-to-1 with each character being a byte long, it's going to still be 18. And Windows 1250, that's going to be 18. One of the, we kind of get spoiled here in the US because Latin 1 and UTF-8 overlap for a lot of characters, as does Windows 1250. And so it almost looks like everything just works with you not having to think about encoding. But whenever you start to deal with these sort of symbols, then suddenly UTF-8 breaks things because suddenly it's taken a couple extra characters when it wasn't before. And on this one, I'm gonna have to just zoom out a little bit. So here's another example. I have Bjorgen, which if I put it into a byte string UTF-8, and I can also encode it as a Latin 1 byte string, but it totally breaks if I try to put that into Windows 1250. It just does not have the character for the O with the tilde over it in that encoding. And so you may have seen this sort of error before, like Unicode Encoder error, saying that this particular encoding just will not work. And so it's able to run the Latin 1, but not that. Or you may have run into something similar where it'll work for Windows 1250, but not for Latin 1. Because here I have no idea how to pronounce it differently, but the O with what looks to me like a quotation mark over it, which will work in Windows 1250, but not in Latin 1 encoding. Okay, the place where this all breaks for me, most commonly, in the sort of things that I do, is when I'm trying to compare a string. I'm scraping some web page, and I'm trying to compare data, or I'm reading in some CSV file, and I'm just trying to say, is this in this, or is this string equal to this, and everything breaks down. So as an example, let's say I have the scraped page data with Bjorgen was here, and I have as a name the byte string Bjorgen. If I try to run is scraped page data not equal to the name, you actually get a Unicode warning that it doesn't throw an exception, where it says, I can't even compare these things because the encodings are different. And it doesn't actually even try to compare them. They are technically, like, if you go from character point to character point, the same, but it's not going to be able to compare them correctly. Then if you try to do, say, name in scraped page data, I get Unicode decode error. ASCII codec cannot decode byte 0xF5. Does this look familiar to anyone, this sort of error? Yeah. So here's the steps I kind of follow to try to solve this sort of problem. First is make sure you know the types of the strings you are dealing with. This is one of those areas where Python 2 is really forgiving about whether you're using a Unicode string or a byte string, and that can bite you because you can get lazy with understanding your types. And I would say that's more of a problem than a solution. That's one of the things I like in Python 3 is that it does a better job of forcing you to be using the right type, where you think of the Unicode string type, str in Python 3, as what you use for text. And you use byte strings for bytes. I strongly recommend adding from future import Unicode literals at the top of your Python 2 files, because otherwise you're going to have sprinkled throughout it where you're doing some sort of literal text comparison. You didn't mean to think of this as a byte string, but it is because you didn't think to put a U in front of it, and it'll bite you later on. It's best if everything is going to be text to just have it be text for all your literal strings. If you ever need it to be bytes, add the B prefix. And then we need to convert all our strings to Unicode strings to perform the comparison. So we're going to pause here for just a moment and try to do this as a group effort.
Hopping by saying this is a really hard problem. Many things.
Yeah.
A friend of mine has a translation company, and he says some of his biggest secret sauce proprietary routine.
Yes.
They've licensed it to the State Department because it's such a problem.
So Greg was saying that this is a hard problem to solve, and you can make money trying to write software to try to translate these sort of issues. Okay.
Good translation.
Thanks. Okay, so given, let's say that we have this scrape data and we already have, let's say we got it from some variable somewhere else, we read it from some file, we have a byte string of Bjorgen Gorgon as our name variable. We want to do name equals and do some sort of mutation on it to fix it so that we can actually do the rest of this code. What do you do?
Then not encode it, whatever it's encoding is.
Whatever its encoding is. And
you have to assign it. I mean, there's no way around it.
you have to say that again?
You have to assign an arbitrary, you have to decide what the encoding is.
That's true. So that's one of the things, at first I'd had a comment on here, but this is going to be one of the hard problems is you don't actually often know what the actual encoding is. There's a certain amount of, as you work with your data, you can see which ones actually result in printable characters and things like that. But I'm going to take advantage of the fact that I know it's Latin 1.
Why?
Huh?
Until it further to say where.
Sure.
I know that people do use Latin 1, but I'm curious, what's the prevalence of non-UTF data that's being created, non-UTF data that's being created in modern computing environment?
So the question is, what is the prevalence of non-UTF-8 data in the modern world? That's a hard question to answer because there's so many different sources of it. As far as on the internet, about a little over 6% of websites are encoded as ISO 88591. And as part of the HTML5 spec, you are supposed to decode anything that is in ISO 885, declared as 88591 as Windows 1252, which is the Windows super similar, but it has a couple of the non-printable characters mapped to some extra printable characters, such as smart quotes. And it looked like it was about 6% are in that. I don't know as far as all the other encodings besides UTF-8 and that, because there's UTF-16 and all those. I didn't look at all those, but at least that one on the web was higher than I thought it would be. I would say when it comes to old businesses, there is going to be a whole lot of them that are generating like CSV files that are in Latin 1. Yeah, or Windows code page, so that Windows 1252 or 1250. Yes?
In Denmark, it's very common for databases to have two columns for name, and one of them is flattened. They call it flattening.
Mm-hmm.
So O dot dot is umlaut in German, but it's not umlaut in Danish. They just flat it.
Uh-huh.
For example.
So the comment was, in Denmark, a lot of companies will have an extra database table for names where they've flattened a column that has a lot of characters that wouldn't appear in ASCII to the ASCII equivalent, such as an O with an umlaut to O. So if we tried UTF-8, where we tried to read it as that, then we're going to get Unicode decode error. And I sure hope this works. We could try Latin 1. Oh. Ah, you're right. I blame you. But let's go ahead and try it with UTF-8. Good job. Okay, which blows up in a different way. UTF codec can't decode that byte, which makes more sense. So now we could get away with Windows 1250, which is not what I was thinking of when I wrote it, but it'll work because none of the characters are actually different in this text than that encoding, which is one of the, again, the super frustrating things is a lot of these encodings have a whole lot of overlap. So one of the questions I have asked myself in the past and what I've tried is using ASCII. In general, I never use ASCII. I would always use Latin 1. It's going to take up the same amount of space, and it is going to be able to translate more characters in reality. So it's just going to blow up less often with the data I work with. So I'm always going to use Latin 1 if I'm having to read an arbitrary byte string and try it out for the first time. All right, now I got to rush back forward to where we were. Okay. I got a little ahead of myself because I was reading that slide. So I never use ASCII, as I said. I do use Latin 1, and I use UTF-8 as much as I can get away with. In general, if I'm writing to a text file and I think of it as text, I'm going to use UTF-8. I have used UTF-16 a couple of times where being able to index into the byte stream was important, but that doesn't come up very much in practice for me.
Why was it important?
It was with a binary file that had text embedded within it. And another solution would be to have a count of the number of bytes at the beginning of it is another solution to that as far as being able to say how long the string is and everything. I don't even remember why in particular. It might have been I just wanted to try out UTF-16, but I have done it in the past, and I have not done it much in the past because, yeah, as I said, I needed it very much. There are, from what I understand, some people in the Asian countries where they end up using UTF-16 more because UTF-8 is verbose enough for their character sets that it's actually kind of bloated to use UTF-8. And that it's just not something I've had to interact with very much. And so I haven't had to use UTF-16 very much. All right. The other big thing beyond just working directly with strings is reading and writing files. I've said it before, and I'm going to say it again, which is that in general, I prefer using io.open versus the bare open. It's the new way to do things in Python 3, so I'm trying to get myself ready for it. It is by default working with text, and therefore if you do not specify an encoding and you do not specify that you're going to be reading or writing and with a B or anything about that, it's going to be reading text. And that will mean it's reading as UTF-8. So here I have a file. I'm reading through, and you can see that it's able to read the file. It looks like this has a check mark, read the file, write the file, still to do, and I had a weird S character. Someone may know the name of that thing. And then the copyright 2017 OKC Python. So it's able to read it. Every line that it gets whenever you're using io.open is going to be Unicode by default. If you want to read binary, you can do that, at which point you get what type string when I printed out the type, which is going to be the byte string in Python 2. And you can see that because this file is actually UTF-8, and there's that check mark at the beginning, that character ended up taking up 3 bytes at the beginning of my string on those 2 lines. And similarly, I'm going to call it weird S because I don't actually know its name, takes up 2 characters in the representation of the bytes. And the copyright, as we noted before, takes up 2 bytes because what we're actually reading is the UTF-8 byte stream. Whenever you read in binary something that was written as UTF-8. Does that make sense to everyone? Any questions on that? Okay. I have a similar file. I dropped the check mark because you cannot represent it in the Windows 1250 encoding, but I do still have the S thing. And you can see that when reading it at read binary, it looks a lot like ASCII for the first part until you get down to the weird S thing, which takes up a single byte, but is unprintable because I'm trying to print out a byte string, and Python has no idea what encoding that string is in because it is a byte string. It is not a text string. If I want it to be able to understand what it is, and it's not just Latin 1, I need to convert it into a text string. If I try to read this file that was encoded with Windows 1250 encoding using RT, so reading it as Unicode, it barfs. I'm showing you this just in case, if you've run across it, the reason it barfs is because you're trying to read as UTF-8 what isn't encoded as UTF-8 on the disk. Okay, finally we're getting to reading with the correct encoding, resulting in Unicode strings. So this is the same file, Windows 1250, and you can do io.open, I can say read RT, and then I can do encoding equals Windows 1250. And that's the way you deal with the fact that it's actually in a different encoding than UTF-8, and it's able to parse the file and display it correctly as text strings. Sorry, Unicode strings. I said I would use the phrase Unicode strings. If what I'm wanting to do is have the same file, and what I'm wanting is what I think of as the common Latin 1 encoded byte strings that I'm used to working with in Python, then you can do it. It's a little bit of work. Use io.open, read it as text. So you're going to get Unicode strings, and then do line.encode to convert it from UTF-8 into byte strings, which will be by default Latin 1. Any questions? All right. Writing files. And I realize I'm going through a whole lot here, but basically I wanted to cover kind of the things that have broken for me in the past. All right, so here's the data I'm going to be working with. I have Unicode data, which is the copyright symbol, 2017 OKC Python, and these are equivalent strings that have been byte encoded. The first one is a UTF-8 byte string of the same data, and the second one is a Latin 1 encoded byte string of the same data. And as you can see, they are not equivalent. For UTF-8, it does take one extra character to be able to encode the copyright symbol. So to write that file, encoded as UTF-8, where what you're wanting to write out is a UTF-8 file, if what you're writing out is starting with Unicode, that's easy. You open the file, you open it in write text mode, and you just call .write and you give it Unicode and everything works great. This is the way it's intended. If you're writing text and you have a Unicode string, text string, then you can just write it out. It doesn't work if you're trying to write out with bytes. The thing dies saying the write argument expects Unicode. If you opened it with write t, it expects Unicode, and we're trying to write bytes, and it'll blow up. So the solution for that is you can decode your bytes into UTF-8 to be written out. And for the Latin 1, which is not UTF-8 to start with, I end up doing something I haven't really shown here. Here I'm doing a decode Latin 1. So the first string, the bytes data UTF-8, that was actually UTF-8 data in that string. That one is a Latin 1 version of that copyright symbol, and therefore I have to decode it as Latin 1, and decode always results in a Unicode string, and therefore I can write it out. Or, alternatively, we can open the file and write to it in binary mode. So if we open it with WB instead, for Unicode, we just have to encode it as UTF-8 to be able to write it out. For the data that is already a UTF-8 byte string, we can just go ahead and write it as is because it's already byte string, perfect for what we're trying to write out. And then here's where I often break and do it wrong. So we wrote a file in binary mode, which is a byte string, and I often don't actually remember because my variables are not named byte string UTF-8 or byte string Latin 1. It's just I've gotten this data from some source and I'm trying to write it out. And so when I'm trying to write it out, this is often where I break down. But to be able to write it out, when I know that, I now know that it is Latin 1, I can call bytes data Latin 1 dot decode, which is going to convert it into a Unicode string from Latin 1 dot encode UTF-8. So it is now UTF-8 encoded byte string to be written out to this file. I realize that's a bit hairy. Them's the breaks when you're converting between different encoding types. Any questions? Yeah.
It seems that Python
Yes.
must have some idea of
The way it can complain, so the question was, if Python can complain about the encoding, it must have some idea what the encoding is or isn't. And it can know what the encoding isn't, like you say, this is the encoding I'm trying to use, because it tries to look up a particular character, like say, it's looking for the byte 253, and it has an encoding table, and there's just no entry for 253 in that table. It's like, this doesn't work. But it doesn't know which of the 1,000 other tables you want to use. That's the problem. So it can say this one won't work, but it doesn't know which of the myriad other ones would be what you want. And the problem is, a lot of them would work for that character, but it may not be the result you want. Like I mentioned, Windows 1250 works largely with Windows 1252, which is the same thing as Latin 1, but there are I think 3 characters that are different. So if you have the same byte in your file, it'll get translated to a different thing when you try to read it as text. There are a couple ways you could do it, but that's the way I've done it. I mean, normally when I've been working with it, I only had a limited number of options. I said there's thousands of possibilities. That's according to Python. According to me, I got 3 options. Because I'm just not working with that many different sources of data that I have to worry about all the different possibilities in the world. And so normally I can find out what it is through trial and error. Yes?
How do you deal, I don't know if you do this, but how do you deal with regex matching?
That's a good question.
Like this slash, like alpha, like the character classes and stuff like that, with the Unicode characters?
Right. So the question was, how do you deal with Unicode, regex matching on Unicode? So the place where I end up doing that is web scraping. And then I remind myself that I'm not supposed to be doing that. But I sometimes do it anyway, because that's the way it works. I normally use LXML. And then, so to answer your question, yes, there are, for the most part, like word boundaries and things like that work the way you would expect with Unicode, at least when working with European languages. And even with the Asian characters, like I've worked with Chinese and Japanese, I am not aware of having issues. But I also can promise that I've had less quality assurance on the output because I just couldn't read it myself. So there could have been issues that nobody ever caught that I'm not aware of, but it didn't blow up. So in general, yes, you can use the regex library, and in fact, there are comments in there on how certain things behave when it comes to Unicode characters as far as, so there's word boundaries, there's case insensitivity, and how that behaves with the different types of O with various characters or whatever, decorations on it. So, any other questions? All right. Well, thank you very much. And I guess we'll see everyone in a month.